everybody. Today we're going to take a look at parallelograms, and tomorrow we'll take a look at quadrilaterals. We'll be studying different properties about each of those shapes, and then going through and solving some problems, figuring out what the missing angle value is or what a missing side is. So today's parallelograms, and the question that we should be able to answer by the end of the lesson is, how can we prove a figure to be a parallelogram and solve for variables in a parallelogram? So first we're going to take a look at looking at their sides. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So I have this parallelogram here, and it says both pairs of opposite sides are parallel. So I'm going to put in the parallel symbol. That's my parallel symbol, and these two are parallel. All right. Next, if a quadrilateral is a parallelogram, then the two sides of opposite sides are congruent. So this side is congruent to this side, and this side is congruent to this side. So those are two things I know about the sides of parallelograms. So the properties of parallelograms, those are two things that we know. Now let's take a look at their angles. If a quadrilateral is a parallelogram, the two pairs of opposite angles are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. All right, the second thing, if a quadrilateral is a parallelogram, the consecutive angles are supplementary. So supplementary means they add to 180 degrees. So I'm going to number them 1, 2, 3, 4. And if a quadrilateral is a parallelogram, the consecutive angles are supplementary. So what does that mean? That means that if I use the numbers that I drew in right here, that means that angle 1 and angle 2 equal 180 degrees. Angle 2 and angle 3 equal 180 degrees. Angle 3 and angle 4 equal 180 degrees. And angle 4 and angle 1 equal 180 degrees. So those are all things that I know. And let me make my one a little, okay, there we go. So those are all things that I know based off of this one sentence. If a quadrilateral is a parallelogram, the consecutive angles are supplementary. So consecutive means they're beside each other. 2 and 3, 3 and 4, 4 and 1, 1 and 2. Next, if a quadrilateral is a parallelogram and one angle is a right angle, then all the angles are a right angle. So that means if I had a parallelogram and we saw a right angle mark in one of them, all it takes is one right angle mark in one corner. That means that every single other one must also be a right angle. So if we see one right angle in a parallelogram, then all of them are right angles. So those are three things we know about the angles. Now let's see what we can figure out about the diagonals. If a quadrilateral is a parallelogram, the diagonals bisect each other. So a diagonal goes from one corner to the next. That's a diagonal. And then I have a diagonal that's going to go from another corner to the next. So if a quadrilateral is a parallelogram, the diagonals bisect each other. So that means that this side will be congruent to this side. So those two tick marks mean congruency. And this side would be congruent to this side. And the last one about diagonals, if a quadrilateral is a parallelogram, the diagonals form two congruent triangles. So I'm just going to draw in one diagonal here. So if a quadrilateral is a parallelogram, then when I draw in a diagonal, it'll form two congruent triangles. So here, here, here would be congruent to here, here, here. This triangle is congruent to this triangle. And vice versa, if I drew the diagonal the other direction, then those two triangles would be congruent to each other. So we're going to start by doing like just a mini proof. We're not going to be doing too many proofs at all. Just practicing our, making sure we know about interior angles and using the sides, angles, or diagonals that we know about parallelograms. So we're going to go through and prove that something is a parallelogram, and then we'll jump into some problems. So again, you won't have to worry about too many proofs, but it's good that we can use our theorems and different things, knowledge points that we know to help us figure out if something is a parallelogram. So here is the first one. Given that ABCD is a parallelogram, we want to prove that AB is congruent to CD and BC is congruent to DA. So we're given this over here. So the key word is that we want to prove it using different reasoning points and things like that so that we can show that AB is congruent to CD and BC is congruent to DA. So first, our statement, ABCD is a parallelogram. What's our reason for that? Because they gave it to us up here. So that is given information. This one we're looking for the statement, but we have our reason. Definition of a parallelogram. We know that AB is parallel to CD, and we also know that BC is parallel to AD. So I'm going to draw my congruency marks over here. We know that AB is congruent to CD, AB and CD, and we know that BC is congruent to AD. So that is definition of a parallelogram, that the opposite sides are congruent. Number 3, angle 1 is congruent to angle 4. So I'm going to draw that over here. Angle 1 is congruent to angle 4. And then angle 3 is congruent to angle 2. Angle 3 is congruent to angle 2. So how do we know that? Because they are alternate interior angles. So alternate interior angles are congruent. So think back to math 2. We got 2 parallel lines cut by transversal. These are alternate interior angles. 1 and 4 are alternate interior angles, and 3 and 2 are alternate interior angles. And alternate interior angles are congruent. Number 4, AC is congruent to AC. Anything is congruent to itself, but the technical name for this is the reflexive property. 5, triangle ABC is congruent to triangle CDA. That is by angle, side, angle. Angle, side, angle, triangle congruency. And last but not least, corresponding parts of congruent triangles are congruent. We know that because AB is congruent to CD. That's our statement. And BC is congruent to DA. So we have just finished this proof, and it proves that AB is congruent to CD and BC is congruent to DA. Again, you don't have to worry too much about proofs and things like that. I did just want to go through and give you an example so we can refresh our memory about properties of parallelograms, interior angles, reflexive properties, and things like that. So that is just an example of reasoning through different things that we know mathematically to prove a point. Now we're going to jump into some examples, and we're going to be finding missing values of a parallelogram. Sometimes we're looking for an angle, and sometimes we could be looking for a side length. So we're going to get started down here. All right. Example 3, and let me zoom in a little closer here for us. All right, example 3. For what values of x and y must each figure be a parallelogram? Lots of different options about going about doing this problem. Things that I know that these two angles form 180 degrees, are supplementary to each other. And I also know that these two angles are supplementary to each other. So I could go that approach. I also know that these two angles are congruent and these two angles are congruent. However, I don't want to go that route because I don't know what they are, so that's not going to help me. So we're generally going to want to put our x's with x's and our y's with y's so we can solve the problem. So one way that I can do, I know that 4y plus 2y is equal to 180 degrees. So these are supplementary to each other. They're beside each other. They're going to equal 180 degrees. So 6y equals 180. Divide 180 by 6, and we got 30. So we know that y is 30 degrees. I'm going to do the same thing over here. I know that these two angles are supplementary to each other. So x plus 5x minus 180 is equal to 180. So I'm just setting up an equation. I know that x and 5x minus 1, I know that x and 5x minus 180 are supplementary. So we're going to solve the equation. add 180 to both sides, and 360 divided by 6 is 60. So we've just found what x and y are. Okay, we just found what they are. Another approach, after I found what y was, I know that y was 30 degrees, and I know that these two angles are congruent to each other. So I could have took 30 and substituted in there. 30 times 2 would have meant that this was 60 degrees. So that would have been an alternate approach of finding the same answer. So lots of different ways to find the right answer. I took the route that they were supplementary to each other. So that's the route that I took. All right, B. Okay, so we got some different things going on here. They're pointing to the different segments that it's equal to. I know that 5x minus 4 is equal to 2x plus 14. So that's one of our things that we took a look at on the front of our paper. If a quadrilateral is a parallelogram, the diagonals bisect each other. So diagonals bisect each other. When you bisect something, that means it's congruent. So two congruent parts. So 5x minus 4 is equal to 2x plus 14. We've been solving equations for a while. Subtract 2x from both sides. Add 4 to both sides. 18 divided by 3, I got 6. Okay, same thing on the other side. I'm going to go through, and I know that x and 2y are congruent to each other. So x is equal to 2y. Having some technical difficulties here, so hold tight.